Hey there, everybody. Welcome back. I wanted to show you a little bit more on the intermediate value theorem. We had gone over this in class, but I didn't show actually pictorially what I was doing. We used a different problem in our class. It had, we were finding the root of a function that had x cubed and other things in it. I wanted to work on finding the root of x squared plus 2x minus 5. Now, I'm not going to show you what the graph looks like until we're at the end, because I want you to see what you would do without graphing it. So I picked a couple points. I plugged in x equals 1 and x equals 2, and I have the word Desmos doing the work so I can see what the y values are. When I plug in 1, I have y equals -2, and when I plug in x equals 2, I have y equals 3. And so I plotted these 2 points right here. And I've got x, or the first point down here, the second point down here. If I do something, I don't know where it's going to cross, but it should cross somewhere between these. It may be right there. It may be right there. It might be going like that. But somewhere it's crossing this line right here. That line is our x-axis, and that's where y equals 0. That's our line where we have a root. Okay, so we know it's between 1 and 2. So I'm going to cross those off and do that. The next thing I did is said, okay, well, let's pick a number that's between them, 1.5. If I plug in 1.5, I get y equals 0.25. So that's still above the y-axis. I'm going to label that 0.3. It's positive. It's still above the y-axis. So now I know if it's going to cross, it's got to cross somewhere between x equals 1 and x equals 1.5. We're down to looking in this region right here. I need it to cross. So what do? I went and tried 1.3. And when I get 1.3, I get a negative value, which is down here, which means it's got to be between 1.3 and 1.5. Again, my window of where it can cross is somewhere in here. Not a lot of wiggle room. But if I'm trying to get to 1 decimal place, that's what I got to do. Why did my pin not go away? There we go. So let me turn on the shading there. And now we're down into that area. So we're getting into a tighter area. I've got between 1.3 and 1.5 right now. And so let's check 1.4. 1.4 ends up giving us a -2.4 right there. So we can narrow it down even further. It's now got to be between 1.4 and 1.5. There we go. So now we're in between these two. And so, like, to 1 decimal place, I got to figure out if it's closer to 1.4 or closer to 1.5. So what I'm going to do is I'm going to find 1.45. And when I get it, it's a positive value, which means I could have x is greater than, which means it's closer to 1 point. I don't want to do this greater than thing. The halfway point is positive, which means it's got to be closer to the positive side. Nope, got to be closer to the negative side. I do want to do that. This is greater than 1.45. So now it's got to be in here. If I'm rounding to 1 decimal place, I'm going to round down. We're going to round down to x equals 1.4. And so what is 1.4 when we plugged it in? 1.4 is -0.24. We're going with 1.4 is the closest value between 1.4 and 1.5. So it rounds down closer to that spot. So what does the actual graph look like? Where is it actually crossing? It's crossing at 1.4495. So rounding down to 1.4 is the correct thing. That's how the intermediate value theorem works to find roots. This might help you pictorially to see what we're doing, narrowing that selection down. And I hope that helps. Peace.